it's almost Christmas. It's cold and snowy outside, and here I am in my beautiful greenhouse, tropical room. I say it's mine, it's not really mine, but share it with a lot of other folks, and I love to come here in the winter because I love plants, I love soil. I'm actually a certified professional soil scientist, and when people ask me what I do for a living and I tell them that, they kind of look at me like, dude, you are weird. I know, I'm one of the biggest nerds on the planet, but there are several thousand of us soil scientists. Why do we study the soil? Because it's really an important resource. It is vital to our health as a planet, as a people. I mean, first and foremost, our food comes from the soil, but also the soil helps clean the water. It provides fuel, fiber, recreation. We love football, soccer, those kinds of things. Guess what? All that grass is grown on, you named it, soil. Buildings, roads, helps control floods, and of course climate. It's an important factor in temperature control, buffers the temperature in the planet, as well as the soils help store greenhouse gases, carbon dioxide. Carbon gets sequestered in the soil. Super important for that and for other reasons too. Societies that have not taken care of their soil have actually had their demise. There are several examples of that in some really interesting study of history. One of the more recent ones, though, was in the United States. Of course, our society didn't kill over, but it was a problem during the Dust Bowl. We were doing some things that were not wise, and we ended up having a bad interaction with the weather, and we got this horrible dust bowl that blew our topsoil all over the place. That topsoil is really important, especially. We need to take care of it and conserve it. We recognized that we were doing things wrong, and we started turning that around. And in the 1970s and 80s, we made major progress in conserving that soil because we recognized as a society that we could not send our topsoil down the river into the Gulf of Mexico and other water bodies. It was important. So having that soil is critical. We need to take care of it. We need to make sure it is doing all the things that it is supposed to do for us. Having good soil health to be sustainable for plants and farms and communities. So what is soil? Well, the official definition of soil is listed here. When I think about soil, though, more simply, I like to think about this interaction of these three disciplines: biology, physics, and chemistry, and how they overlap and interact is a really important part of what we do in studying soils, especially when we're applying soils, like so many of us are trying to do when we're growing plants, for example. When we talk about soil biology, biology is the study of living things. So soil biology is the study of the living things that are found in the soil. What kind of living things? Well, we have all sorts of things. We have macrobes, which are larger things like earthworms that you can see with the naked eye. And then we've got microbes, which you can't see. Those are things that we commonly refer to as germs, bacteria, fungi, viruses. Those types of things are found all over in the soil. Some of these are pathogenic and are not so good for whatever plant is growing there, but most of the organisms in the soil are good and they contribute to the health of plants and other organisms. They also help build the soil and create aggregation and water and nutrient holding capacity, and even act as a source of nutrients for those organisms. We look at the soils like here. These are cutaways that we have, and we can see what's pretty typical is that towards the top, this soil came from Okinawa, Japan. You can see the accumulation of topsoil towards the top. That's because of those living organisms that are dying and excreting things and are contributing to that soil being dark and having that high organic matter level that's typical of topsoil. Not all soils are like that. Like this guy from southern Utah, it's really just kind of red all the way down. There hasn't been much living organisms in the top, so it really hasn't developed much topsoil because it's in a desert. But these other two are similar to this one. High organic matter in the topsoil, characterized by that darker color. And that again holds things together. It's kind of a glue to take all of those soil particles, the sands, the silts, and the clays, and kind of helps bind them together into soil aggregates that help keep water and air relations in the soil moving and healthy. Soil aggregates, or what normal people call dirt clods. But aggregation is an important thing that happens in soils. It kind of helps hold all those individual soil particles, the sands, the silts, and the clays, holds them together and creates pore space, spaces in between the soils that allows water and air to move through and into the soil. So that's really important. When we talk about these aggregates, some of them are stable and others are not. I have a little test that I do in the field. I just take some water and put it in a cup, and I take my aggregate and I drop it in there. And if it dissolves very quickly, it's poor aggregate stability. I've got another aggregate here that I'm going to put in, and we'll drop that guy in there, and we'll just see how long it takes. Now, that first one I dropped in, it's already dissolved. There's very poor aggregate stability. So that means if I put that out in my landscape, as soon as I hit it with irrigation water, it's probably going to fall apart. This other one hasn't started to break down at all yet. So we'll put that down, let it work for a few more minutes. One of the things we know, we get these different colors of soils. We got, this is almost white. We've got black. We've got everything in between, reds, yellows, all sorts of colors. One of the things we've learned is that typically lighter colored soils tend to have poor aggregate stability. We find those down in the lower parts of valleys, next to lakes and rivers, because those aggregates have already broken down, and then they were carried away easily with the water as rainfall and snow comes and we get runoff. Those soils move down to the lower parts of the valley. The aggregates that are stable, they tend to stay put in the upper elevations. You'll notice that my dark colored aggregate there still hasn't broken down. The other one is completely done for. Soil physics sounds pretty nerdy and pretty ominous, because physics sounds ominous, and it is. It is a very difficult science. Soil physics is some difficult stuff, but so important. We study a lot of things, such as energy relations in the soil. Probably the most important thing, as far as I'm concerned, is the soil-water relations with regard to soil physics. Water movement into and through and being stored by the soil. The soil structure has a big impact on how that happens. If there's very poor structure, and what I mean by that is I don't have much pore space in between soil particles, the soil has a difficult time having water and air also moving into and through it. And so a good soil, a healthy soil, has good soil structure. Now, a lot of things will affect that. How compacted a soil is. If you run heavy equipment over it, it can destroy the soil structure and have very poor water relations and air relations in that soil. And those plants need both water and air in those roots. So it's important to have those things. The other thing that will affect it is the texture of the soil. When we talk about texture, we start with rocks that break down with weathering. Eventually they become so small that we'll classify them as soil instead of rocks. The largest size soil particles are sands, the intermediate are silts, and the smallest are clays. The clays are really important because they have the highest surface area and water and nutrient holding capacity. How all those things fit together is important. We call that soil structure. We need good soil structure because in addition to all these minerals and organic matter that's in the soil, we need water and air. We need both of them. And those are found in the pore spaces in between the soil particles. So good soil structure, a healthy soil, has enough air space, pore space, that it allows that air to move into the soil so that roots can get to it, but it also allows water. And so we need this kind of this mixture, balance of water and air. How much is in there depends on how compacted the soil is. Most native soils have good structure. Soils in the urban environment, in the agricultural fields, oftentimes have poor structure because we're driving over them and we're kind of destroying that structure. Another factor that is at play there is the texture of that soil. How much sand, silt, and clay, what those percentages are, is what we call soil texture. You can see that on this soil textural triangle. Each side of the triangle represents sand, silt, or clay, and we can determine the percentage of each and come up with a category of soil texture, such as a sandy clay loam, a loamy sand, or a clay. And all of those factors impact how a soil will behave. Okay, so if we want to look at how water moves through a soil, and we can see a little demonstration here just with texture. This soil has very poor aggregation and it's mostly clay and silt. And I'll put some water in there, fill it up to the top. You can see that, set it down. Nothing's really happening too quickly there. And that's really true for a lot of soils. Here's my sand. If we do the same thing here, we're going to see, whoops, that water moved all the way to the bottom of that in just a few seconds because there's so much pore space in the sand, it's already dripping through the bottom. And my other one is just sitting here. We haven't infiltrated water into that soil hardly at all. If we come back several hours from now, it'll be moved down through a little bit, but it's going to be really slow. When we're talking about soil chemistry, we're talking about the periodic table of the elements. All of those elements exist in the soil. Some of them are nutrients, some of them are toxins, most of them are salts that are needed by plants, but also in excess quantities can be harmful for plants. We're talking about the pH of the soil, which can affect how nutrients are soluble or insoluble, and toxins as well. All those things are important for plants. Plants need those nutrients, need to have an absence of toxins, and we evaluate soil chemistry. This is our lab where we do testing for soils to check the pH, check nutrient concentrations, check salt concentrations, those types of things in order to evaluate whether a soil is healthy and able to support plants or not.